Excellent. Right, thank you. So as this part of the slide says, I'm Steve, and this part says we are Team Similarly Geeky, and we've been playing with Apiphonica. So when we started, we were looking at the Bob a Job problem, which is kind of interesting. Most vendor systems are fairly straightforward and balanced. You have someone that wants to buy a lawnmower, you have someone that wants to sell a lawnmower, they both go to eBay, everything's simple. But this is because they are balanced. They both have good computers, they are both tech savvy, they probably both have a PayPal account. But the Bob a Job is imbalanced because the person who wants their garden mowing might not be computer savvy. They might not even have a computer. Whereas the person that is able to go and mow their lawn probably lives on email, doesn't use the phone. So we started on this road for a little while until we realised, hang on a minute, I have this problem in real life. The problem I have in real life is that I work in an office. That's not the actual part of the problem. I live in an office that's a bit like Alcatraz, with three differences. The first is people intentionally go to Alcatraz. There have been 3 documented cases of people escaping from Alcatraz, and you can get a phone signal in Alcatraz. You cannot get a phone signal in my office. And this was the problem we actually ended up solving. So, what we did is we created 2 hacks, ultimately. The first hack was an Apiphonica Node.js library. This is primarily because I don't do Node.js, and I wanted to kind of wean myself into it and not be scared of it anymore. So this is the library that we created. It's now up on NPM, and it does most of the standard things that Apiphonica does. It's only the basics, so if we go to some code, these are the module exports that we currently have. So you can query the countries that it supports, you can buy a phone number through the API, you can send a text message, get the information about the text message, and place phone calls. It's only the bare basics. As we say, it's a hackathon, so doing this quickly as possible. There is one interesting point to note about the Apiphonica stuff, and you have 2 numbers. All of the numbers provided will do text or speech, but not both at the same time. So there's a couple of little pieces in here which kind of remove that complication. The second hack that we built, we called Roam. So what happens in Roam is that you send a text message to an Apiphonica number. The number gets sent to our server, which is running the Node.js code down here. It has to look at the calendar, so it goes off to Google Calendar, it downloads the calendar, and it says, where is Steve right now? And at the moment it says, right now, the best way to get in contact with Steve is using Slack at work. The application, it looks at the Slack at work, it looks at my address book, it says, right, well, this is the Slack channel Steve's going to be in, and then sends me a message. So Lily, if you send me a message, it can be anything, preferably something nice. The world is watching. So that will come through, it will go first off to Apiphonica, and there we go. I've been summoned. Is another message coming through? Okay. So what we're doing now is something slightly different to what you'd see upstairs. Because we've got no phone signal here, normally it would go through via SMS, so we're just going to be pumping it through Slack as a sort of a stopgap. So the message would normally come in via SMS to the Apiphonica. Apiphonica would send us a message, we then look at the calendar, and then the calendar then sends a message on. So if I go to the calendar now, and I change this to, for example, email personal. That's how you spell email. And if you can send them another message. It's empty. I'll restart the server. What that's sending is, because we have conduits, the message can come in from Apiphonica. We've also got one of these. It's an Arduino with an ICB radio on it. And what we've also got down there is another one of these. There we go, sent by email. It has another one of these. So what we've got is a button. So when you press the button, it summons me. There we go, you've been summoned by Lily. And again, that hosts it off to email. So that was sent via email. So there we go. Oops. There we go. TADHack box, message transfer, hello world, and you've been summoned by Lily. Of course, that can come anywhere. You know, you could send that from SMS to email. You can send this back via SMS as well if you like. So if we continue on, the word roam, by the way, it is for reach me everywhere. Or if you prefer the international spelling, it's reach me anywhere. Or if you can't read, it's also roam, because I'm roaming and I can be accessed anywhere. So we've got ability to send messages in through any kind of conduit. We process them, we look at the calendar, and we send them out through any conduit. So someone could email me and it will get redirected to SMS if I happen to be out. Apiphonica doesn't have text-to-speech currently, but we did find an online thing called Vesmo that does. Or rather, we found a website that we could scrape to do it. So what we do in one of the conduits is we generate an MP3 file using this external service. We then serve this MP3 file up to Apiphonica, which then plays down it places a call to your phone, and then it plays the MP3 down to the phone. And this was all well and good. It solves the original problem we had of me not being accessible. And also accidentally managed to implement Bob a Job at the same time. If the calendar is not like this, instead of saying, well, I'm available on mobile or I'm available by email, you could change the meaning of this to say, currently, Tom is available for gardening, or Jack is currently available for gardening. So when someone calls through saying, I need a Bob a Job to help me, this could actually be a scheduling calendar, and it will automatically forward the call or the message onto the person that is going to be doing the job. So accidentally solve that problem. I then made one line change. I changed this code, which reads the summary of the calendar, and split it according to the comma. So now we can put multiple outputs in here. So instead of just going to email, it can go to SMS on my mobile, it can go to Slack over at work, and it could go to, what else have we got? We could send it to voice. So now if a message is sent, it will go to all of them. You can see the little red flash there has come up. It's come through on there. It's come through again on here. And if we had some mobile signal, you'd hear this buzzing with a text message and calling me with a text-to-speech that has been created online. And in doing this option, where you can put multiple things in here, means you could put SMS person 1 or person 2, or all of them. So we've also accidentally solved the American school problem, where a teacher comes into an area and says, I'm going to be in this area teaching English on Wednesday. They could put all the students that they know are in that area into the calendar, so when the teacher says, I'm going to be coming here, it automatically sends out to all the kids in the area via SMS, because they don't have smartphones, they don't have access to all the clever tech that we've got. Although, say accidentally solving the African school classes is probably a little bit too grandiose a term, it is at the end of the day just sending messages. But I think that's mostly what we managed to get done. Anything I've missed, Lily? No. Okay, so those are the hacks. I was going to say in a nutshell, but that would be an enormous nutshell. So unless there's any other questions from Alan on the floor, I shall hand the microphone back.
Thank you so much. Great job as always. Do we have any questions for Steve? If not, again, thank you so much. Right, moving on. Who wants to be up next? Come on, don't be shy. Here we go. Come on, guys. So just take your time, get yourself set up. Once you're happy and ready to go, just let me know. Okay?
Do you have a phone for a signal? We've got two phones that got signal. So if we just need to ring a number 300.
Yeah, I mean, I've got that number as a US number.
I just need you to ring someone to ring that number.
Oh, okay.
Part of our presentation.
Yeah, okay.
Anyway, we'll just fill it in. Because
Yeah, you got
a
signal?
lot of people don't have signal.
My 2G link isn't reaching. Just put that in there.
Got HDMI?
Maybe GA.
What's really going to...
Right, so let me just... No, for them you need to go.
What we call it the jack,
Oh, it's not working on yours?
No, we're using multiple phones.
Oh, gotcha. Somebody's got their speaker on.
Can I give it to someone on the stick? Okay, yeah, so when
Thanks,
I'll call the first one. Yeah, so
You just get anyone.
Yeah. Who has to talk? Okay. And you do the topic. Hello everyone. We're PhoneGuard. We start off by looking at the, what's it called, Pay Me to Talk, the very first challenge. Basically, people get tens of millions of unwanted, unsolicited phone calls every day, waste their time. A businessman actually took a company because he charged them a minute for every minute, he charged them £10 for every minute he was on the phone to them and took a small claims court and actually won. So we thought, how can we charge people to ring you if we don't want to talk to you? So we created PhoneGuard.
So basically, the technical solution is very simple. We're using API Phonica, and what we do is we provide every person who wants to use this service with a PhoneGuard number. It's basically a public number. It's what you would display to the outside world. It's what you put on your LinkedIn or anything like that. And so we run on the assumption that people will generally only have access to that, and you would only give out your personal number to family and friends. So what happens is once a call is made, it's obviously intercepted, and we receive an API call, and then based on that, we look into our account to see if the person who's trying to call you is registered with our service, and if not, his phone call is rejected. So he has to register with the service and pay a certain amount of money to give someone a call. And this is kind of a niche market, mainly for people who really don't have time to answer phone calls, because sometimes if you're working, I don't know, as a developer or anything, sometimes even 1 or 2 minutes of your day can throw you off, and it'll take you about 10, 15 minutes to get back. So that's really primarily what it's for.
So the basic, I'll just talk on it. So the basic principle is you put in an amount, you make a call to that person, and then so if your call is really short, they hang up on you, you lose all the money for that deposit, and it's a sliding scale. As the length of the call goes up, the amount you pay goes nothing. So if that person actually wanted to talk to you, and you're on the phone for a certain length of time, there's no cost to the person. So we actually got to work a demo. I'll try calling it now. Let's see if the best volume and signal.
He's trying to call me, by the way.
Oh my goodness. Sorry, Edward. Let's try it.
The volume is pretty low, no?
Sorry, how do I turn the volume? So basically, it runs through his gone account already, and he's got no credit, so it rejects the call.
So yeah, basically in that case, Mark had an account. Mark had an account. He tried to call me, but he had insufficient funds in his account, so he wasn't able to proceed with the call. In this case, now I'm going to be calling Mark, but I do have some balance in my account, so I should be able to get through to him.
And also,
The number you have called is protected by phone guard. This call will cost you a maximum of £1. Costs will decrease depending on the length of the call.
so if any one of you, so and then he forwards it through to me. But so if any one of you call this number,
You can try it yourself.
and I don't know why it's not on the screen.
0203-411-9806.
So if any one of you call that number, you'll get a recorded message rejecting the call. So if anyone wants to try ringing that, you should get an automated message telling you basically we don't want to talk to you. No one? Anyone? Anyone want to signal? No, no signal.
No one's listening. Oh, here's someone's trying.
Yeah, try ringing that number. Yeah, so you should get a message saying you don't have an account. Please pay us money.
Cool.
Yeah. So that's the principle. So if you really want to get through to them, you're willing to pay, and you know maybe the person being rung every time they hang up, they're getting money off you for wasting their time.
Cool.
Thank you.
Excellent.
Questions? Any questions? No? Thanks.
Thank you.
Great, well done, guys. What we're going to do is we're actually going to turn this off. This is creating reverb on the live stream. So it was great you broke back into just using your voice, because it was just going to be reverb. Let's try and turn it up. There you go. Okay. Right. Who wants to be next? Come on down, guys. Get yourself set up. Oh, sorry. But I know Dean Buckley is going to love your hat, because he's the guy that suggested that pay to talk to me. So,
we didn't actually mention Epiphonic, did we? That we used
oh yeah, that's right, yeah. I know. It's, you look what we did. Oh yeah, who's supposed to be judging it? Okay.
Got an issue, mate? Yes, no, it's the problem with Max on it.
Yeah, it's just my Mac's got, it does this when it's got something.
Okay, there you go. It's just depends on the part.
There's a change.
No, because it says
Picking that resolution.
There you go.
Right. So the problem we wanted to try and solve was the difficulty of remotely doing design sessions. Often when you're planning things together, you'll have a whiteboard and you'll be drawing diagrams out. So we wanted a way of doing that more easily remotely and sharing these diagrams and charts that you draw by hand. So we came up with our team name, State of the Chart, using a pun generator. I'm quite pleased with it. So we've got our code managed through the video.io API. And if you want to...
So this is the other end of the call. So if you connect and we'll connect.
Good. Okay, cool. So we've got a call going, and the next thing we did was to try and do a bit of machine learning, image processing, and a little bit of OCR that we're using the TADHack API from Google. We ran into some problems with the OCR because it turns out it was trained on a printed data set, so our solution was a very carefully drawn test case. But obviously, with the right training data, it could learn handwriting like that. So what we're going to do is we're going to hope for the best here because it works sometimes. The problem with live demos. Oh no, it's not doing so well there. Yeah. Hold on a second. Just, with. No, it's fine because it doesn't. Nope.
No.
There we go. Oh, awesome. Well, he had a good shot.
Yeah.
Okay. And then the next part of the idea was we were going to try and keep this whiteboard that we could then edit in sync by using the Matrix API to send sort of real-time updates to it as we edit it. But unfortunately, this is working. You know, it's the problem with live demos. The problem we had, we couldn't quite get the Matrix server running by the time, so we sort of shoehorned another solution in, and we didn't end up integrating Matrix in the end. But if you're prepared to take my word for it, I'll tell you that this sort of live updates thing was kind of working in a different way.
So you could interact with the whiteboard, move stuff around.
Sorry?
Try again.
Hold on a second.
We'll have one last go.
Just,
It does work.
Well, eventually, yes, but no, that's not really working. But we can at least share updates as they are.
The idea is that you would be able to.
Yeah. Go on then. Yeah, I think the lighting's different now. It's all different. There you go. If you're willing to take our word for it, that did work. But unfortunately, you're not using Matrix.
No problem. That was great, guys. Thank you so much. So that was using video for the screen share.
Yes.
Yeah, that would work.
That worked fine. That's great. Thanks so much, guys. Okay, do you want to come on down, guys? Get yourself set up.
Well,
What's the name?
Yeah.
So this is just the old school display board, chain it together.
on the USB-C.
Yeah.
Okay.
We'll need to get in.
Yeah, just so we share.
Okay, those stats. Seconds of resolution. Oh, you're just in there.
No, you're
oh,
plugged in.
No,
yeah, plugged in. I have to.
Okay, sorry.
This is VGA, unfortunately.
VGA?
Oh, wow. Okay. It's probably the Mac encoding for HDMI system. Okay, we all listen. Oh, yeah, sorry, got to share. Are you saying just going to swap that in there?
This should already be connected. That's already in.
Yeah, it's all connected to the screen. I'm going to mirror the screen up here. The silence. Cool. Right, so I can see that. Right. Where's this measure? Fingers crossed this actually scales. Oh, well, there we go, we did that as well. Yeah. Cool. Everyone ready?
Yeah.
Show us up.
Go for it.
Right, so we're One Vision. What the idea is a sort of combination of web development, our marketing person, and myself as the mobile developer, Leslie. So what web, how come I don't have notes, sorry, okay. So the tech stuff we did, we used Temesis as our delivery platform for messaging and video. It doesn't have to be Temesis. Due to compliancy issues in the States, you have video, VC who are very much HIPAA compliant, whereas Temesis will probably be compliant for fire in Australia and stuff like that. So it's designed as a delivery platform for health or even just social. It doesn't necessarily have to have any compliance issues. Right. So, since I don't have user notes, I'll do it on the fly. So the objective is to deliver an easy way for users to do day-to-day stuff, for instance, pay bills, deal with medical conditions for any age group or ability. So that means anybody with a physical disability, mobility, right down to digital issues. So I wish I had my user notes, so I'm just going to copy it, so that makes sense. So this is to remove numerous friction points for the user who gets lost and frustrated while talking to the provider, allowing solutions used by any age group, physical or digital ability. I'm just getting a bit flustered here. Okay. Cool. Right, so as we all live lives like this, we all have well-being, visibility. It's great. I mean, life is perfect. In no ways will life ever look like this. So if you take what is ideal and what life is, that's where we come in and we do this. We just hold life in its place. The idea is not to control your life, but just to help you with the day-to-day stuff. So, you want to carry on?
So I just wanted to say, so with our particular app then, ours is the glue that brings together all of those separate life components in an easy, seamless way of being able to be used without being flustered whatsoever.
Yeah. Well, do you want to
keep going?
Okay, cool. So the well-being facet is, I'll give you a scenario. We have blood pressure cuffs. Now, blood pressure cuffs for a doctor, the doctor sits there, puts it on your arm, everything's calm, you relaxed, everything's good. When you take it home, a blood pressure cuff to put it on, I break into sweat and I'm dexterous. And then you take a measurement, it's high pressure, and things start going wrong. So a lot of alarms fire off, and then doctors need to see you and everything else, especially with the post-acute care in the States, where the idea is to keep them out of hospital for at least 90 days so that your care providers and all that will get penalties if they come back into hospital. One of the features we have is that when the user puts the cup on, the care provider can say, sit down, have a cup of tea, and actually trigger the measurement remotely. So that's where One Vision comes in. It's the glue that will say, blood pressure cuff, hit the button, and it actually does something on the user side. So the user doesn't have to panic or have to know how anything works. These are just some of the areas we cover. We deal with things, for instance, another problem is we've got here secure video calling, that's for your care providers. Environmental management, we've got IoT integration already. We've already using the Temesis API to send secure messages to the device and adjust temperatures by thermostats or whatever the device is connected to.
transportation, these are just some of the areas where they're fit. And then there's this one, finances. A lot of providers will offer you to check different plans and stuff like that. We don't want them to leave the video call to do that. So they'll pop up with the video plan, they accept it there. We even want, with the Temesis system, we could record and do a voice acceptance of a particular policy. And then that can be uploaded to the provider directly. Okay. Friends and family, that's no problem. I know we're a bit rushed for time. I want to get to the demo. So I've covered the medical. We've got, these are currently the items that I've already integrated into Android. I haven't got in the demo, unfortunately. Wellbeing dashboards, all the data is consolidated at the back end. A keynote is we don't want to build a system that manages all this. Our system is an extension of existing systems. It's very important to realize that we don't want to build health plan management systems and all that. There's huge companies that do that. We just want to offer the veneer on top of that. Okay. Social, everybody knows social, everyone knows Facebook, but to a lot of seniors, it's quite a daunting task. So this is the idea of just simplifying the process down again. Utilities, this is where I'm saying, for instance, utility companies come up with a better plan for you. They can immediately push the information to the device. You can then accept it. Anybody who's got a physical disability can do a voice acceptance, which can be recorded, which is great. We have IoT integration, monitoring. IoT, unfortunately, is one of these things of there's so many cloud providers out there, anybody can do it. So it's very cool that we can push directly to the device. For instance, if you've got local devices like Philips lights and stuff like that, you can actually control it because you're on the same network. Okay. Security, everything goes across a secure channel, so we're all good. Cool. Okay. Right, so demo, this is going to be a really quick demo. Just switch it quickly. So what we have is we have the initial call, which will then connect to this provider over here called Daniel. We've done a big visual area where the provider is. This is an IoT device on the local network, and this is where all the new policies or offers come from, and you can just select and go into it. As Daniel hits the button, you'll see the temperature will start increasing or decreasing. Give it a second, it'll be here now. It's here, but we'll see it.
It's taking some
There we
time.
go, yeah. It's a screen share.
So we have the admin, let's say the caretaker's interface over here, and we can control as soon as I get connected to him, I receive all the data from his house, let's say. So like the temperature readings and I don't know if all the windows are closed or any sort of data. And from here I can control, so I can, let's say if it's too warm or too cold, I can adjust the temperature just by using the chat system of Temesis.
And also then remotely we can make sure that our client is secure in a variety of different ways, or push notifications to them to say, have you taken your medication? We notice that your medication hasn't been taken today, or please make sure that these particular doors are locked at this particular time prior to, say, like going off to sleep. So there's the secure way where we can help our clients as well.
And that's it.
Excellent, thank you so much, guys. That was a great demo, well done. Okay, who wants to be up next? Come on down, guys. Let me just move this around a little bit so everybody sees what presenting is going.
So, this is a team, spent some time today working on this. And so what we want to present today is that, as you're aware, with all the technology advances, that communication has become so much easier, whether we're connecting online, whether it's Skype, WhatsApp, etc., and all these those social platforms. So while it's a great way to keep in touch with our friends and family and those who we care about, communication nevertheless can bring out, that is meant to bring out the best in us, can also bring out the worst. So we have seen throughout social media platforms such as, you name it, Twitter, Facebook, etc., trolling has become commonplace, unfortunately. And with anyone being able to make comments to other people, whether they're in a toxic or aggressive manner. And this impacts hugely online communities where you just simply want to have a safe environment without the negativity. So therefore, our idea is that what if we could use machine learning to develop a tool that will allow us to classify those negative comments in a conversation to improve the overall online communities. So now I'll hand you over to Rob that will tell you a little bit more about this technology.
Okay. I'm going to try and do this actually through medium of website. That might be the best way to do it. So we came together yesterday morning. I came to TADHack with a germ of an idea to do this. And the first part of the problem was, how do you build a classification engine that can do intelligent stuff and do sentiment analysis, which is more than just happy, sad, one-dimensional. And I have to kind of admit, I've been thinking about this for a few days before I kind of landed yesterday morning, and read a really interesting paper that the Google Jigsaw folks did with Wikimedia project called Wiki Detox. One of the things that they did was actually paid Cloudflare to go through about 110,000 Wikipedia chat comments and classify those with these 3 dimensions of toxicity, attack, aggression. And I thought, wow, that's actually quite a good place to bootstrap this. So if you could take that and apply that to online chat, it was designed for something else, it was designed for Wikipedia comments, that would kind of allow you to build something that was at least bootstrapped and added value from day one. But that wasn't really the objective of the hack, so we built that, we put an API together, and the API just kind of looks like this, so it's a bit of Python. You fire in a request with a bit of text that you want classifying, and you get back your request plus some results. Just because of the size of the neural network you need to build, that's actually a Boolean on each of those. It would be nicer if it were probability, but you need a kind of a big server to train that and a big server to serve that, and serve it quickly as well. And I've just got my little private Google Cloud Server account to serve that off, so that's quite limited. Put that together to deliver that, so we've got an API that flies back, and you can go and play with that. I've served it up on api.polite.ai. Don't hit it too hard and destroy it, because especially as you're in the demo. So we got that API, and the next thing to do was to connect it up to Matrix. And Joe, who isn't here, Joe, who is it? Come on, Joe, come down, because Joe did nearly all of the work yesterday.
I forgot to bring my medal.
He's done a tough mudder this morning? Spartan. Just astonishing. So Joe did a ton of work actually getting that together and turning it into a Matrix bot. And the Matrix bot does some smart stuff, so let's demo it. Actually, if some folks in the audience can jump on #test:/matrix.org, and let's... wrong thing. Right, come on, let's have some abuse going on here. So okay, we've got a bit of abuse and toxicity here. Now, this kind of demonstrates what the real potential of this is. So yes, okay, using the Wiki Detox stuff, it can pull up a read on it. But what we then do is give you a link and go through and go and appeal, and so it didn't pick up toxic message, so I can hit a button here, which if it actually worked, and we didn't quite get to that bit, would allow you to generate this text in there that we then store back in the database, have a human being go and review this. So this allows us to build up a corpus which is way bigger than that sort of 100,000 Wikimedia corpus. So that essentially is what we've done. Where's it going? I'll do that through the medium of website and other stuff as well. So we put together an open source project. We figured if you're going to do this for a hackathon, might as well have an open source project. It's got a bit of a manifesto, because you can't have an open source project without a manifesto.
It's also got a license, importantly.
Yeah, it's got a license. So there's a WordPress site with a manifesto. There you go. About improving the way we communicate and plugging into stuff. It's got a GitHub repo. And as you can see, there were some things that we would like to have done that we didn't kind of get around to. We've done all the usual stuff of writing those acquisitions, so being honest about the stuff that we were hoping to get done for the demo, the create report challenge form, and deduping room events, so if you re-invite it, you get a whole load of spam back about things it just found. Yeah, I think that is about it really. This is Polite AI. Anything else that I've forgotten? Go invite polite-father Ted matrix.org to your matrix room if you feel like it.
Polite-father Ted.
No, it isn't actually. That one got a bit toxic because we invited it to a room it didn't have permission to access and it keeps crashing now. I don't know why. Talk to the matrix guys about
I
that.
guess, and
that was most of today, by the way.
So the overall is that you can create different chatbots, so they can have different personalities to help moderate the chat. So you can invite them to your chat to help, as an open source, build that database of words that are classified within the free groups, of toxicity, etc. So we did have a play, or the guys were having a play at creating different chatbots, so that's also something that can be expanded into as well, to take some different personalities to help you.
We were going to troll through Kim Jong-un's Twitter stream and Trump's Twitter stream and pick out different personalities out of that. Probably going to
Well, interesting. I had this presentation in my head as I was thinking last night, and for the classification engine, I did at one stage think about just plumbing various toxic Twitter streams into the classification engine, but it actually doesn't work like that, because even when you look at toxic Twitter streams, they're mostly non-toxic. In terms of where this is going and where it could go, obviously this is what we've hacked together at TADHack. I actually think there's quite a germ of an idea here around properly open source and community owned classification engines for this kind of thing, because trust is everything when you're going to give a classification engine the ability to go and moderate, or I'd like to say mediate, online conversations. And I quite like the idea, and the project team here quite like the idea of being entirely transparent about this. So building chatbots that can go and learn and build a corpus of knowledge that they can learn from, and getting involved in open source projects and those communities to teach them things about human interaction, and then open sourcing that to allow people to pick that up, rather than this kind of knowledge of what's acceptable in discourse to be buried inside large corporations. That just is, kind of a thing that I think might be an important thing. So I'm quite interested in the idea of taking Polite AI forward as a project. And any folks in the room who are interested in that, I'm quite happy to get other people involved in that.
Great, thank you so much, guys. Excellent hack. And we've witnessed the birth of yet another open source project, which was cool. So who would like to be up next? Come on down, guys. Remember to mention the resources that you built on, okay? Which one are you trying to? Is there HDMI? No HDMI break. Oh, your PC?
I have it, yeah.
Okay, yeah.
But I've got a USB 3.
Yeah, we got USB 3 here. You should be able to use the HDMI because it's a laptop.
It's worth shot, yeah.
Here we go.
So wait, which one is it? Is it here? Is this it? Oh, that's what
Maths. Should get here then.
Just about.
Just takes a little bit.
That just
Okay. So who wants to explain it? Yeah, let's start. Okay, so our project's name is Culture Room, taking inspiration from the...
I'm Chris. I'm actually a first year student, and this is my first hackathon. Yeah.
Yeah, so I'm Jordan. It's also my first hackathon as well.
Waves, it's first hackathon. Yeah.
Glad to be in my second.
And I'm Emmanuel, the experienced one with a few of these hackathons. So, yes, we took inspiration from
one of the sponsor ideas. So I think that many people around the world have different backgrounds, and sometimes it's not that we refuse to talk to them, it's that we don't know how to approach different people from different backgrounds. So somebody from Pakistan might not understand the culture of my country, Taiwan. So we created this platform that that uses natural language processing, that gives compelling suggestions, so that you have chat suggestions to, even if you're an introvert, you can know what to talk about.
And
you can understand even different languages, like what we were talking about.
So for the technologies, we used a few things. We used Temesis for the message sending, and video for the actual video call. We used the NLTK Python library to extract the entities such as places, things, people from the messages, and to actually grab the images, we used Microsoft's cognitive services to pull images off of Bing, or the URLs, and
to get relevant information, we use the Wikipedia API so that we know what they're talking about, and we also use the local weather API and IP address. Yeah.
So there's a screenshot of it there.
So anytime, anywhere, you can initiate this call.
Let's get to the demo.
Yeah.
So. Wait. Oh no. Oh. Very professional. Someone have to cut this out.
You're ready.
No, it just came out of the presentation. I'm still late to a resolution. Yeah, swap to Alright, here we go. So, let's log in. And yeah, let's get in a call with test user number 1. So there we've got the, so there's 10%. Sorry.
So if I type something like hola.
Let's have a look.
Yeah. Send this.
And then I get suggestions about.
You get the most relevant suggestion in the chat box. So hola means hi in Spanish, and then some people might just stop at a hi. So hi, how are you? Yeah, nice weather today, and you don't know how to continue. So we improved that by giving 10 suggestions. Can you scroll down a bit to give you chat suggestions on how to improve, how to continue your conversation. Yeah. And if you say like I'm from London.
Okay, sure.
Let's try this. So if you say that I'm from London,
it doesn't. Yeah, it doesn't pick up on London properly, but that's actually the second part of this demo, which is the natural. And my laptop dies. Oh my god!
You wanna try it?
Yeah.
I don't have the natural language processor.
Is there a PowerPoint ready?
Yeah. Plus you have. Oh, I think it's a battery. It's battery.
Oh,
Yeah. It's literally a
We are really sorry about this.
Very sorry about this.
Yeah.
Yeah, we'll wait for it to.
All right. Alright, so if I head to Okay. Yes. Alright, here's the second part. So if I say so what was supposed to happen was the text "I'm from London" should come through here. So like this. So backend gets the request, processes it with ignore that. Oh my goodness.
And it sends a picture of London.
And it'll send back a picture of London.
Yeah.
Very
So
nice picture.
it recognizes that the London is actually a location entity, so it will send back exactly the London. It will do a search and then.
Yeah, in this demo, it actually displays the picture, but what was meant to happen was that URL was sent to the front end, and then that picture is displayed. So that was the idea. But we just couldn't get it working. The finish line was so close.
We were so close.
We were so close.
That's excellent. Well done, guys. Excellent. Again, what I think it shows us is just so much more innovation around chat, as we've seen in so many ways. So, who wants to go next? Matt? We can go next. It's not working. But oh no! But it was working, wasn't it?
We have quite the Occupy guys trying to troubleshoot.
Excellent. No, that's good. That's good. That's perfect. Yep. Come on, Dan, get yourself set up.
You'll have to jump wall, but
yes,
Yeah, we're not using amplification because we get lots of reverb. So we're just using voice here. The microphone's there and it's picking it up good on the live stream. So I think you're both posing, weren't you? You're both posing. Yeah, it's like, yeah, you don't need to use it. Perfect. Cool.
Well, you hope optimistically it might suddenly start working more.
I'm quite optimistic.
Ready to go?
Yeah, whenever you're
Cool,
ready.
cool. So I'm Matt, and this is Yin Yi, and we've been hacking on getting Project Clearwater running over Reno. Doesn't quite work yet. So what are these things? So Project Clearwater is an open source IMS core. It's built to be cloud native, so kind of built on the same kind of design principles as a lot of web scale up applications. And if you ever want to play with it, there are all-in-one VM images. It's really cool. I work on this. We've been trying to get that running over Arena, which is the recursive internetwork architecture. And that's basically intended to be a better replacement for pretty much the whole stack below TCP and below. So it replaces TCP, it replaces IP. So you have to not have TCP and IP running below it, apart from the fact you can actually tunnel it over UDP, and that's what we've been trying to do. And then we're trying to run Clearwater on top of it. And there's various different implementations. We were using R-Lite. This is the network. This is the architecture diagram for Clearwater. Quite complicated, but the key thing is that we've tried to make these links, these HTTP links, run over Arena rather than over TCP. Say questions to the end, please. The way this actually works in terms of Clearwater's implementation, we use curl, which is a standard C library for HTTP requests on the Sprout and Bono side, and we use a thing called libevent-HTTP on the Dime side. And basically we try to migrate both of those so that rather than using standard TCP, we use Reno instead. And in fact, that's what we've ended up trying to do. The code is the same, but we've even failed on that. So. In terms of deployment, we've been running on EC2. We've got 4 nodes of Bono, Sprout, Diamond, Development nodes you saw on the previous slide. Because we're running in EC2, we're running over the top of IP. Fundamentally, EC2's Amazon's thing isn't Reno enabled yet. So you have to run over IP. And so what we're actually trying to do is tunnel this over UDP, which when we started this project, we didn't realize was not very stable, and the Reno developers knew this. They actually pointed us to use Ethernet in the docs, but we didn't notice that bit. So that's why it may have gone a little bit worse than it should have. So demo, unfortunately not. We've got to the stage where we've written the code on both sides, and we've seen it trying to use the Reno APIs, but actually the UDP connection that I mentioned just isn't stable. So Marco, who's the guy from ArcFire, is currently trying to troubleshoot that. We're reasonably confident there's nothing to do with that code. I think he is too. That doesn't mean there aren't bugs in that code. So next steps, get it working, probably the main one. At the moment, let's say we're only doing HTTP. That was because it was kind of the most obvious one to do. In future, we just do SIP, which is the main protocol that IMS core speaks. Just do that over Arena. And then there are various other protocols that we use internally. That would be good to do as well. One of the challenges with some of the protocols, so both SIP and diameter stuff from this, is that obviously if you're using these protocols to talk to other things, they've got to talk Arena as well. So there's a challenge there. And then the other thing to do is actually to assess how good Arena is. It's supposed to be better than TCP/IP, but obviously a lot of that is about proving it out in real-world applications. And the other thing is actually, did we do the right thing at all? So we changed the code in this curl library, we changed the code in this libevent-HTTP library. It would be great if actually you didn't have to adapt every single library your application uses to do this. So I've got a couple of slides. This, I'm afraid, is almost just slideware, but I went running this morning and thought this is the way we should have done it. So the way that applications tend to work at the moment is you have your application on the left, it talks BSC sockets, which is like the standard networking API, to libc, and then that does system calls into the kernel. And so you have like a whole load of different calls, get host by name to do DNS resolution, you have sockets and connect and so on to actually manage TCP connections. Whereas if you're using librena, so you're using the Arena code, then you make a Arena open call rather than a socket call, and you use register and flow alloc in order to manage your connections. It'd be really nice if we could build this, which is basically that your code on the left talks the standard BSC sockets calls, and we have this Arena interposer library, which I'd like to write, which gets its configuration from files or from environment variables, and determines whether a given connection, given a library or whatever, should be using standard TCP or should be using RENA. If it should be using RENA, it diverts it via the RENA API. If it should be using standard TCP, then it just talks directly to libc, and then it all magically works. There's a little bit of fun here because obviously this code still is thinking in terms of IP addresses, so you have to kind of pretend that you were doing IP connections even though you weren't. So it's a bit of a halfway house, but it would mean you get a lot of applications running over RENA very quickly. And I did do a prototype, this is running the code. This is running a standard tool called netcap, and I've provided various details about my RENA configuration on the environment variables. And there's this magic command or a magic environment variable called LD preload. And what LD preload does is it basically tells the operating system that rather than loading libc like it would normally, you first of all load this magic library that can do the mapping. And so I'm calling the socket calls, and that actually maps through to a RENA call, and then I'm calling the connect call, and that maps through to a RENA call, which fails because unfortunately app connections aren't. But yeah, that's the idea, and all that stuff is up on the internet, on my GitHub. So Sprout links are around for the Clearwater components. RENA interposer is my attempted interposer library, which hasn't been tested very hard because of the issue we've been having. And yeah, thanks to Alan for organising and Miguel and Marco for the support.
Excellent, thank you so much,
Thank
guys. Clearwater has been something associated with TADHack since its beginning.
Yeah.
The first hack of IMS in minutes was built using Clearwater.
That's right, yeah.
And how far we've come. Now we're running on top of a completely new version of the internet.
Yeah. No, it's all pretty cool.
Excellent. Thank you so much. Great hack, guys. Okay, I think we've got two to go. So, do you want to take your one now? And what we'll do is, once we've got the pictures all done, I'll get some snacks and some booze set up upstairs so you can relax. And then Luke and I will go through the judging. As I said yesterday, even though it feels a long time ago, we have the local prize. Okay, so we'll be sort of deciding that today. But then what's happening over tonight into tomorrow are all the global prizes are getting decided. So each of the global sponsors has money they're allocating. So for example, Matt didn't hack on any of the sponsors that are funding that grant that we have for London. So that gets entered into the global prize judging, where the ArcFire team will be looking at all the hacks that have been built up on ArcFire. And as you can see, it is uber geeky, so there haven't been that many.
Let's give it a second.
Just click on it and then here you go.
So that's a mess. Can you do a plan? That's a little count. So hey everyone, I'm Aviral. I'm here to present PushTime, which is an application that syncs your computer with your phone over the Matrix network using the Matrix protocol, and it's completely secure. It can be end-to-end encrypted, so it's a very good solution. I'm not a big fan of doing presentations at hackathons, so I've got the demo right up. So starting with the first use case, I think a lot of us are developers. When we sit down at our desk, we hate getting out of the zone to go and find our phone. So you're in a meeting and you're like, where's my phone? And so I have the first solution for that. You can open up this thing and you can go ring. So you can go find your phone using the ring function.
then all of us have this problem. We keep winning hackathons and people keep sending us money. So we've got to open the bank site and, you know, see whether we receive the money. So yeah, and who hates entering that one-time password from their phone? Everyone, I think. So what I've got here is push time can automatically enter one-time passwords for you. So I have my number here. Can someone send me a one-time password? The one at the bottom. Read it out. 7519 573 308. So send me a 6-digit numeric PIN code with any other text. That's fine, but it should be a 6-digit PIN code. Anyone text?
Make sure the number again.
Let's check the number. 7519 573 308. There's no signal? Maybe I can send myself a message. Yes. That works. So here is the OTP, for example. So obviously a bank won't send you something like this, but you know, you can send any OTP, and then once it comes to your phone, what you're going to do is we're going to pick up that it's a one-time password, and the extension is going to detect that, and it's going to ask you, do you want to fill in the one-time password automatically? So you can do that and it just works. So also you have this case where you want to call some number and the number is given, you've got to go and enter it in your phone. So that's really annoying. So I have a solution for that as well. If you have a number that's a link in a browser somewhere, you click on it and it automatically pulls up the number on your phone. Then who hates, you know, somehow emailing yourself the contents of your clipboard from your laptop to your phone and then from your phone and back? So I also have bidirectional clipboard sync. So for example, if I type in, let's say, you know, just let me copy this entire URL and copy that there. So I have my phone here and I can go and paste, and it is going to paste in that. So that's synced over the matrix network. Similarly, if I copy this message, sending SMS through push time, and I copy that, I can go back to my browser and it should be synced. There you go. So that's not all. You also want to send SMSs presumably. So I have an interface for that. If anyone wants to get an SMS from me, maybe meet for drinks later. But yeah, I don't remember my own number. Let's see. The space on the screen is not doing many favors. Good point. Good point. So yeah, it does notification mirroring as well. That's a part I missed out. If you get any notification on your phone, it shows up on your laptop as well. So yeah, there you go. That works. Testing, sending, SMS. And you click on send and message send. And then